As the number of qubits is scaling in the quantum computers, it becomes more and more difficult to actually keep track and tune them and characterize them and actually calibrate them. So with that growing challenge, there are a couple of companies that have set sails to solve this problem. One of them is QuantrolOx, sorry. And today we are going to check out this company. So if you want to learn more about them and if you want to know what all of this is about and how they might also set themselves apart from other companies in that space, then stay tuned for today's video as we are diving right into QuantrolOx. So let's get started. Here we are on their website. So it says QuantrolOx. I'm practicing. I will at the end be able to say it the right way. And it says the Qubit automation company. So what do we see here? We see some cryostat, which is a cooling system, mainly here. So solid state cryostat, probably things like superconducting qubits. And then you see that there's some software interface here, which goes through different steps, accelerating the future of quantum. And then Quantum Edge by QuantrolOx, which is probably the product accelerating the future of quantum. So that is also, I guess, the mission, accelerating the future of quantum. And here you see a couple of names like Maybell, the European Innovation Council, Oxford Instruments, Qblocks, and so on and so forth. So there are a couple of names that we've seen already before in the series, or QEDC, Quantum Machines. So they're all names that we've already seen. And if you haven't seen the videos on those, then make sure to go check out our Hidden Quantum Champions playlist on the YouTube channel, because there you can actually see more of these videos on those companies. So here it says more than 100 times faster, bring up characterization tuning. The current pace of quantum development is slowing value creation and needs acceleration. Qubit bring-up, characterization and testing processes take days. The current industry benchmark for a single qubit is 1 to 2 days. We help to maximize your time. And let me quickly take a step back on why this is the case, why this is actually so complex, and why this is needed. So, a couple of years ago, or let's say in the early days, you would probably have, I don't know, one new chip in a research lab made every year. So then you have a lot of time to actually do your testing. Why do you need to do this testing? It is because if you're looking at these solid state systems, they are, let's say, macroscopic quantum systems, so quantum systems that are composed out of many, many atoms. That is a difference to, for example, ion trap computers. In an ion trap computer, you have one specific sort of ion, and this is just one atom where there's one electron removed, so it becomes an ion. So think about, I don't know, helium. Helium has 2 protons, 2 neutrons, and then there's 2 electrons on the shell. So if you remove one of those electrons, you have an ion, and they are always exactly the same. So they always behave the same. So if you, for example, take a specific laser frequency, you can excite the whole ion into a certain state, and this will always be the same, independent of how you produce these ions. As long as it's the helium ion, it will always be the same. And of course, people use rubidium lasers and whatever type of ions. I will not go into the details now. So it's much more complex, right? Now, for the solid state systems, it's a little bit different. There are these Josephson junctions, for example, for superconducting qubits, and they are junctions made out of superconductor. So superconductor could be something like, think about the first one, I think, was mercury. So there are metals, big metal pieces, big, I mean micrometer size, maybe nanometer size, but many, many atoms, like many, many atoms. But still, if you are putting them into a superconducting state, you can describe them by a single wave function. And that's what makes them interesting, because suddenly all these atoms behave collectively like a single quantum system, a Bose-Einstein condensate. And that is why they are ideal to make qubits. Now that is the theory. Practically, there are a couple of things that make them different from each other. I was talking about the Josephson junction before. So the Josephson junction is, let's say, a insulating gap between two superconducting pieces that might be connected to something like a circle like this. Now, this insulating gap, this has an effect on how the actual physics might be working. So if you are making it differently isolating, so if it's not perfectly isolating, but maybe there's some conductance going on or there's some impurities happening, suddenly that changes the properties of your system. The same is true also for spin systems where you have, let's say, doping atoms that are embedded into, I don't know, for example, a silicon crystal, and you want to manipulate them. They are also a little bit dependent on the local environment. The same is true for nanowires and whatever you want to think about. So all of these systems, the underlying properties of the microscopic underlying properties of these atoms that they are consisting of, they somehow still kind of shine through. And that makes them, let's say, different from each other. So two qubits that might be produced on the same chip in the same way, they might still be a little bit different. And then kind of creating that system and locking them together with each other, connecting them with these radio frequency lines and kind of tuning the connection between those qubits is kind of challenging. So it is a complex process. It is easy for a single qubit, but as soon as you start having two, you suddenly not only care about the individual properties of these two, but also about how they interact with each other, how they work as a system. So suddenly you have to also characterize these things. So now you want to characterize, does the thing work? So does it actually become superconductive, for example, when you cool it down? Does the individual qubit work? Does the other individual qubit work? And does the coupling between those work? And then you might also want to know how well do they actually work. So you want to characterize what is the error rate of the single qubit, what is the error rate of the entanglement gates, and things like that. So suddenly you see that this problem becomes increasingly more complex, especially as you add more of these qubits. And now looking at industry, we actually see two things happening. On the one hand, we have more and more qubits, right? So companies with their roadmaps are now showing that they want to ramp up the number of qubits. So there needs to be some quality control. And then on the other hand, you see that, okay, as these companies become companies and not just research labs, they also want to sell those products, right? So suddenly it's not like you want to do one chip per year, but maybe you want to sell every month one of these systems, or maybe later on every week one of these systems, or every day one of these systems. And suddenly you have to build a whole chain of, let's say, testing equipment and everything that comes along with it, quality monitoring of that. And I think that's where these type of companies here, or in particular, QuantrolOx is coming in. So here it says present control methods require 3 to 4 experts just to manage 10 qubits. With Quantum Edge, one expert can easily manage multiple quantum computers. And that's kind of the promise that they make. So Quantum Edge, qubits automated, we have a solution. We bring automation, speed, and productivity with Quantum Edge. Automation is the only way forward. Quantum Edge automates tuning and optimizing superconducting quantum computers, cutting fundamental experiments times to seconds, and simplifying complex tasks like randomized benchmarking. And then here you can book a demo with them. Now let's quickly check out the products. So one of them is this Quantum Edge that we've seen before, right? So that is, I think, the test system, right? So Quantum Edge automates tuning and optimizing superconducting quantum computers. So this is only for superconducting, cutting fundamental experiment times to seconds, and simplifying complex tasks like randomized benchmarking. So this is using, well, as the name suggests, it's randomized way of benchmarking those qubits and then kind of measuring the quality of your chip in a way. You can focus on innovation while ensuring your systems are ready for future success. And here you see the cooling system and the software kind of control of that. And that's the interface here. So Quantum Edge is an advanced automation platform designed to streamline the tuning, optimization, and scaling of quantum computers. Whether you're a pioneer aiming for future scalability, a researcher experimenting with smaller systems, or a scientist swamped by two qubit gate characterization, Quantum Edge enhances your productivity by automating complex tasks and reducing experiment times to mere seconds. With Quantum Edge, you can focus on innovation while ensuring your systems are ready for future success. Automation is the only way forward. And there's also a video here which I guess demonstrates it. Then there's QPU monitoring as part of it. So the QPU monitoring tool provides a graphical view of the QPU. So QPU is quantum processing unit topology with real-time updates on qubit performance metrics such as coherence time, gate fidelities, and error rates. Users can adjust these metrics across hardware setups and integrate with major control electronics for detailed insights. And here you see what such a topography would look like. So here you see the different qubits, I guess, as colored dots. And then you see the couplers between those. There might also be some which are not working. And then that's what kind of the chip would look like. Or maybe these are in testing, I don't know. Automation workflows. So Quantum Edge automates qubit bring up, characterization, and tuning on a QPU through tailored workflows. These workflows comprising control segments for rapid measurements and detailed analysis include QPU bring up, single qubit optimization, and 2 qubit gate operations. Users can customize and build workflows as needed with options to debug and rerun from failure points. This automation boosts efficiency, accuracy, and reliability, ensuring optimal quantum hardware performance. And then finally, there's the data visualization part. So the data visualization tool streamlines the extraction, visualization, and interpretation of data through interactive plots, enabling quick debugging and deeper insights. You can easily explore data, prioritize key information, and share analysis results instantly with relevant teams. Product highlights: develop and scale up your qubits with Quantum Edge. And then here are the target things like pioneer seeking scalability, research small systems, and scientists overburdened by 2 qubit gates are, let's say, 3 cases of why this, for whom this might be interesting. Okay. What is interesting about this is, and that maybe sets them also a little bit apart from others, this is really focusing on the software. So you see, I think up here it said something like integrates with major hardware suppliers or quantum control suppliers. With major quantum electronics for detailed insights. So I think they're not focusing on building the electronic system, but more like building the software layer that helps you to automate this in your existing lab setup. And yeah, I think here it's really mostly about lab setup. So focusing, at least from how this looks like, focusing on helping researchers to actually focus on research on the quantum chips and not on, let's say, characterizing those and learning how to efficiently test the chip. Because yeah, in a quantum lab, you also need to have chips more often. But I think also there's some industrial interest of that going to happen in the future, and possibly for, let's say, the big quantum companies that are looking for, let's say, scaling up the activities and looking at their roadmaps. Companies like this one here might also be interesting to look at, just as a side note if anybody's watching. Then there are a couple of frequently asked questions. I will not go through all of these now. And then here you can see they are, for example, integrated with QuantrolOx or Zurich instruments, which of course we have featured already earlier in this series. And then how to get how to start using it. Let's start together. Getting started with Quantum Edge is simple. Once we confirm your qubits have compatible control electronics, like for example QuantrolOx, quantum machines, or Zurich instruments, all you need is a software license. Our engineer will handle the installation, and within 1 to 2 hours your system will be configured and ready for experiments. Our scientists will provide training, ensuring you are up and running quickly. And then here you can get in touch with them. There's a second product, which is this one here, Vidyakra, a connected, scalable, open architecture platform for education, research, testing, and benchmarking. And I think here it also goes into the hardware side of things. So here we see a cryostat, we see some control electronics, there's also a chip in here, and of course the software side of things. And it says that it's a complete quantum platform with cryogenics, control hardware, and QPU powered by Quantum Edge. So this is for educational purpose as far as I understand. A whole system so that you can actually kind of buy the full solution to get started with your experiments. Start experiments on day one, customize without constraints, and expand over time. True open architecture. So why Vidyakar, Master Superconducting Quantum Hardware with Quantum Edge Academy, the ultimate learning tool for anyone who wants to master superconducting quantum hardware. Very good, as of course it is the mission of this channel here to democratize education in the space of quantum technology. I encourage you, if you want to learn something about superconducting hardware, then you might want to check out this Quantum Edge Academy because that might be an interesting source to learn. Then freedom to innovate with SDK, build your own libraries by implementing new experiments in Python using your preferred tools, support your hardware roadmap by independently testing and benchmarking cables, electronics, QPUs, and amplifiers, and more. Easy to upgrade and scale. Open architecture allows any library to run within electronics on any superconducting QPU. No vendor lock-in. Can be installed as a single system or a centrally managed system of systems. Built-in automation, so Quantum Edge superchargers bring up characterization and tuning, so your team can focus on discovery and not bottlenecks. And then proven design, so developed and tested 24/7 on the world's most flexible quantum computing reference system with multiple electronics, QPUs, and cryo components, delivering unparalleled quality and adaptability. What you get is a Blue Force as a cryogenic solution, a QuBlocks cluster for the quantum control. Then there's the Conscience QIB2 versatile 7-qubit superconducting chip, and the Quantum Edge software for the automation. And then, who's this for? University labs and government research facilities, industry R&D teams, and then consortia and innovation hubs. On top of that, there are a lot of listed resources here, so you can find publications, videos, news. Let's quickly check out the news articles. I'm recording this beginning of 2026. You see the latest news here from December 2025, so pretty much up to date. It says QuantrolOx unveils the Vidyakar, so what we've just seen, the world's first true open architecture quantum platform. And there are also other points here in the list of news articles down here. Starting with 2022, where they raised 1.4 million pound in funding. Also down here, I think, let's see, they have a Finland office. So yeah, there's a Finland office, and there is also a UK one listed down here. So a European company. Then let's quickly check out the values. So the company values: we promote human flourishing. All our activities should contribute to making the world a better place for the environment and all who live in it. This underpins our company's values, respecting individual dignity. We trust people to do the best job possible. We provide appropriate tools and training and fair compensation. We foster teamwork, diversity, inclusion, kindness, and respect for life beyond work. Dealing ethically with everyone, we shall do what we say when we say, our partners, suppliers, and customers. We aim to meet our or exceed expectations with our high standards of excellence. And then number 3, generating long-term value. We are committed to transparency and effective engagement with shareholders, listening to their voice of experience and returning value to their investment. And then quickly check out the team also of the company as per usual. So here we see the team, a team of recognized scientists, leaders in quantum control and experience in building deep tech startups. We see here the founders, which I think are these 4 people here. You see chair, chief executive officer, chief scientist, and director of product. Then below here we also have researchers, technical leads, engineers. So all the types of functions that a proper company needs. There's a VP of business development, business controlling, financial. So you see that this is like a proper company from the setup, and looks like a lot of very nice and intelligent people on here. With that, I think we are already at the end of today's video. If you found this interesting, then please make sure to subscribe to this channel if you don't want to miss out on the next one. And then, of course, if you want to see more of those videos, go check out our Hidden Quantum Champions playlist with many, many more of these types of videos. And with that, as always, make sure to stay hydrated and see you in the next one. Bye-bye.